Hello, welcome to Saving Grace Homeschool. My name is Leanne. Today I will be discussing the differences between metals and nonmetals. The learning objective is to understand the difference between a metal and a nonmetal, and the success criteria will be based on your ability to find metals and nonmetals on the periodic table, to describe the properties of metals and nonmetals, as well as to classify an element as a metal or a nonmetal. Here is an activity in which you can sort the different cards into two groups. It is based, well, it's up to you about which property you decide to sort them out. So over here, it was sorted into whether they are a metal and a non-metal. So the metals include sodium, gold, calcium, copper, and iron. And the nonmetals are neon, carbon, sulfur, helium, and nitrogen. What do you notice about where the elements are positioned in the periodic table? So when looking at those elements that we classified into those two groups, these are their different positionings. So you'll have that the blue are all your metals and your yellowy orange color are your nonmetals. There is a red line that you can draw going across the last block over here, and everything to your right hand side will be your nonmetals. Everything to the left hand side of this line will be your nonmetals. I'm sorry, will be your metals. So metals is on the left, nonmetals is on the right. Hydrogen is a nonmetal, but it is often put here in the middle. The periodic table has now been colored in according to whether those elements are solid, liquids, or gases at room temperature. So you can see here that all the metals besides mercury, they are solids at room temperature. So this tells us that their melting point is very high, because to be a solid at room temperature, it means that your melting point needs to be greater than 20 or 25 degrees Celsius. In comparison, many of your non-metals have low boiling points, so they are gases at room temperatures. So you can see you have your metals on the left-hand side as being solids, and then you have your non-metals, which are, they can be solids, liquid, or gases, but they are mainly gases. So that shows that they have low boiling points. All right, so can you tell whether an element is a metal or non-metal from its state at room temperature? So you know that if it is a gas, it has to be a non-metal, because the metals over here don't include any gases. So if it's a gas, it is a non-metal, and then if it's a solid or a liquid, it can either be a metal or a non-metal, where you have your bromine and your mercury are liquid at room temperature. Here is a investigation to be able to determine the properties of metals and non-metals, but I can't do that as I don't have the element at hand. So if you would have it, you could have decided if it was shiny, if it was ductile, malleable, brittle, magnetic, a good conductor of heat and electricity, if it's sonorous, or if it had a high density. We are going to be having a look at some of these properties with examples. So even though we can't physically do it, we will do it in the following slides. Here are some questions that we are going to be answering. So the questions are, if you were given an unknown element, how could you work out whether it is a metal or a non-metal? What typical properties would a metal have? Are these properties the same for every metal? What typical properties would a non-metal have? And are these properties the same for every non-metal? So we are going to be having a look at this in further detail now. Why can't we use a magnet to work out whether an element is a metal? This is because not all metals are magnetic. But all magnetic materials are made of metal. So you've got iron, nickel, and cobalt. So iron, nickel, and cobalt, they are metals that are magnetic, but not all metals are magnetic. So if it's not magnetic, it will not be attracted to a magnet. So just because it is not magnetic does not mean that it is not a metal. So far, we have just looked at the physical properties of metals and nonmetals, but metals and nonmetals also have chemical properties that we need to consider. When an element reacts with oxygen, it forms a oxide. So carbon and oxygen put together form carbon dioxide. That di over there just means that carbon reacts with two oxygen atoms. Then copper and oxygen form copper oxide. So over there, it shows that copper is only reacting with one oxygen. Then you have that when non-metals oxides, when they dissolve in water, they form acidic solutions. And when metal oxides dissolve in water, they produce alkaline solutions. So non-metal plus a water is an acidic solution, a metal and a water is an alkaline solution. There are certain properties of metals and nonmetals, which I will be discussing in the next slide. So metals are shiny, they are good conductors of electricity, they are good conductors of heat, sonorous, they form, well, oxides of from the, they, oxides form from alkaline solutions, they have a high density, and they are malleable and ductile. Then you have nonmetals, which is the opposite. Instead of shiny, it is now dull. They are poor conductors of electricity, poor conductors of heat. They are not sonorous. Oxides are formed from acidic solutions. Sorry, acidic solutions are formed from oxides. They have low density. They are brittle. So those were the different um, properties of metals and non-metals. But there will always be some exceptions. Some exceptions of metals and nonmetals that don't follow those properties that are laid out. For example, coal is a form of carbon that does not conduct electricity. Carbon is a nonmetal. Then you have graphite, which is also a different form of carbon. So both of these are different forms of carbon. The one conducts electricity and the other one does not conduct electricity. Some further exceptions is that some metals have a low density, although most of them have a high density. And because some metals have a low density, they are even able to float. Silicon, which is a non-metal, is shiny, whereas most non-metals are dull. So you see how they go against the predicted properties. We normally think of metals and non-metals as two complete opposites, but you get elements that have properties of both metals and non-metals, and we call these elements metalloids. All right, so we have different results of a test that was carried out where they tested the different properties of three elements. And from these results, we have to decide whether the element is a metal, a non-metal, or a metalloid. So having a look at conducting electricity, we know that non-metals do not conduct electricity. So that will be so far number 3. And we know that metals do conduct electricity. So it's between these two. This is possibly the metalloid because it only conducts electricity at high voltages. Is it shiny? So metals are shiny. Once again, this says that this is a non-metal because non-metals are dull. Then we have brittle. We know that non-metals are brittle and metals are not brittle. So far we have that this is your metalloid, this column is your metal, and this is your non-metal. When it is malleable, metals are malleable, non-metals are not. So this must have the property of a non-metal, meaning it is your metalloid. The same with ductile, none of them are ductile. So it's a metalloid, a metal, and a non-metal. Because metalloids have the properties of both metals and non-metals, you would expect them to find them here on the border of that red line. So that border separates your metals from your non-metals, and on this border over here, that's where you'll find your metalloids. Now the question is this a metal or a non-metal? It is able to conduct, here's your substance. It is able to conduct electricity as seen by the light bulb being switched on, so it is a metal. We look at cobalt. Cobalt lies to the left of that red line, so it is a metal. We have a green gas. All gases are non-metals at room temperature, so it is a non-metal. For this one, it is this over here is a metal because all magnetic substances are metals. But remember, it's not to say that all metals are magnetic, just that all magnetic substances are metals. And then over here, we need a bit more information to be able to determine whether it is a metal or a non-metal. But because it is dull, you would expect it to be a non-metal. So a metal is a substance that conducts electricity, is shiny, is not brittle, is malleable, and is ductile. And that is all for this lesson about the different properties about on metals and non-metals. I hope you have a clearer understanding. That's all. Thanks, guys. Bye bye.